Hi there. We're now ready to move on to our second topic in the course, our second objective, which is chapter 15, chemical equilibrium. So hopefully by now you have kind of sense of what the expectations in the course are, what a typical exam is going to be like, what the homework assignment is going to be like, and then what the virtual labs are going to be like. So the timing is not so bad during the regular semester, during the fall. We have about 2 weeks for every chapter, and we have 1 week for every virtual lab. So the timing shouldn't be too bad. You'll learn to sort of plot your schedule around getting these topics done. Each person has their own technique, their own method, their own study habits. So you'll need to work on that for yourself to figure out what works for you. Now, I want to make a couple comments about chapter 14. In some ways, it's a very challenging topic, a very challenging chapter for the beginning of the course. There's a lot of math in it. There's some conceptual ideas, a lot of notation, stuff like that. Chapter 15 is very similar, but I think what you'll find is that the work you did in 14 will help you in 15 because some of the things are very similar, some are different, but it's really not a more challenging, it's not a more difficult chapter than 14. Okay. I will be over the next few days going over exam 1. There are certain problems in which if it has multiple parts and you get one part wrong, the software will mark you wrong completely and you get 0 credit. So I will be going back over the next few days. It takes some time to see if there are problems that people did where they got some of it right and some of it wrong so that you can get some credit for the part that you got right. Likewise, sometimes there's a little bit about notation that's not quite exactly what the software expected, or significant figures, that sort of thing. So I will do my best to resolve those issues. Expect that to happen this week, okay? A little bit about we started the virtual labs a little bit late. I wanted to start them the first week, but there was a little software glitch on that, but we're up and running now. So hopefully you can start working on the second virtual lab. And I did want to mention something about, let's come up here. Oops. Where we're at here, okay? So again, I'm recording this on Monday night, so you have until midnight tonight to finish the lab. The virtual lab will be due next Sunday, and then you're working on chemical equilibrium as you go along there. Okay, remember there are practice exams for these, so you can also work on those. Okay. The other thing I wanted to just give you kind of like a brief little intro into, into equilibrium. And I do recommend that you watch the videos on YouTube. I have a lot of videos on YouTube, which you can use to help you with the ALEKS problems and such, okay? So, just really briefly, the idea of equilibrium, it turns out it's related to kinetics. But the idea is, imagine that we've got, we start off with some little container here. Make this a little bigger for you. This little container right here. It's like a little tube. And that tube there has this molecule called N2O4. There's 2 nitrogen atoms in the middle and 4 oxygen atoms surrounding it, right? N2O4. There's a bunch of them in a container. And what happens is over time, the N2O4 might react. And so over time, it's really just splitting apart. It's just breaking into 2, quite frankly. So over time, you end up with some NO2, right? NO2 is half of N2O4. So you have this new molecule here, a product called NO2. And so notice we have a mixture here. And notice how the color is changing. It's going from clear, it looks white, or gray, it's supposed to be clear. It's turning brown, and NO2 is a brown gas. Over time, it gets even a little more brown, and what you end up with is actually quite a bit of NO2 and just a little bit of N2O4. And we would call that equilibrium. We would say that at equilibrium, there's a mixture of NO2 and N2O4. The N2O4 does not completely react and form NO2. We get a mixture of the two. And that's an example of what we call equilibrium, chemical equilibrium. So take a look graphically what's happening. We start off with N2O4. We don't have any NO2 to begin with. Over time, the N2O4 goes down, 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 and then it stabilizes. It doesn't seem to change anymore. Likewise, the product NO2 is going up, 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 up. Now notice the NO2 actually goes up more than the N2O4 goes down. I don't know if you have an idea why that's the case. Why would NO2 go down? I'm sorry, why would N2O4 go down less than NO2 is being, than NO2 is going up? And the reason is every time an N2O4 reacts, it actually forms two of the NO2s. So the NO2 actually changes twice as fast because of that relationship. But nonetheless, at some point, both of them are pretty stable. You have a mixture of NO2 and N2O4. And this is what we call equilibrium, where the concentrations are no longer changing. We call that equilibrium. Okay. So you're going to look at that and you're going to do calculations, watch the videos, read the book, and do these ALEKS problems, and you'll be okay with it. They're actually connecting this now to rate, which we often don't do till later in the chapter. It turns out the rate of reaction, what we call the forward reaction, so we have the rate constant Kf times the concentration of N2O4, looks like a first order reaction, right? N2O4 is reacting. In fact, that's a little decay like we saw in chapter 14. Remember those little decay curves that we saw as the concentrations were changing for the reactant? Same thing. There's a reverse reaction where NO2 goes back. NO2, two of them, they combine with each other, they react and reform an N2O4. So this is called dynamic equilibrium. Both processes are occurring. The forward reaction where NO2 is, I'm sorry, where N2O4 is forming NO2, and then the reverse reaction, R for reverse, where that is actually forming the N2O4. Both are occurring at the same time. So you'll see these double arrows in the notation, okay? There's none of it shown right here, but you'll see the notation there, okay? So good luck on chapter 15, chemical equilibrium. We're gonna use the concepts that we learn in chapter 15 in chapter 16 when we do acids and bases, and chapter 17 when we do buffers and titration curves, and in chapter 18 when we look at equilibrium from the perspective of thermodynamics, and even a little bit in electrochemistry when we look at the, I think it's chapter 19 when we get to that, okay? So a lot of work ahead of us, but we're now headed into it. Reach out to me if you have any questions, and take care. Good luck with everything.